Hello, welcome to the webinar on building a modern recommender system. The agenda of the webinar is we'll take you through few terminologies to help you understand the context and you don't miss on it. Key takeaways from the webinar. What is a recommender system? Evolution of the recommender system and organization strategy, which will cover benefits, why, and either do you want to build or buy, and the GTM strategy and the future of the recommender system. At the end, we'll take up Q&A. Please feel free to jot down all the questions. Our organizer would take up the questions and we'll take it at the end of the webinar. I'm your host, Rahul Sudeep, Director Marketing at AppsTek, and the man of the hour, Prasanna. He's the Associate Director of Data Science, who will take you through the entire webinar. Before we begin with the recommender system, I'll just briefly take you through our journey as AppsTek and also our solution landscape. So it's been 15 years we're in the market with 150 plus engagements, 400 plus skilled experts, and the thing that we are proud of is we have got 100% client referrals. We incorporated in 2007 in Dallas. 2000 to 2011, we were building our clientele, specifically BFSI, manufacturing, industry, energy, utilities, and utility verticals. In 2011, we started our offshore unit in Hyderabad, India. In 2012 to 2017, we were expanding to UAE. In 2018, we had AppsTek 2.0 when we started focusing on cognitive and emerging technologies. With a goal to improve our process to deliver excellent service and solutions, we took up CMMI certifications. By 2022, we were appraised at CMMI 2.0 Dev Level 3. In 2022, we also expanded our footprint to Canada. 2023, with security as a core focus, we got certified for ISO to 27001. Then on 2023, again, we became a NASSCOM member, where our core focus was to engage in policy advocacy, collaborate for innovation, and enable skill development. With tech partnership, we have with Microsoft, Oracle, Boomi, and Snowflake. So here is the service and solution landscape. From Oracle, we have cloud implementation, SCM, financial and HCM, e-business upgrades and new features, implementation ECC, testing services, managed services for cloud and e-business applications, and also DBA services. Digital engineering, we are focused on CX, web, mobile, both. Low-code Power Apps and SharePoints, application modernization, cloud transformation, and also digital integration. Cognitive, we have computer vision and IoT. Data analytics is also a core focus where we talk about enterprise BI, big data, data engineering, enterprise warehouse, data lake, data cloud, master data management, data governance, data science, advanced analytics, and data visualization. With managed services, we have infrastructure management, which has 24/7, 365 monitoring, platform support, technical support, application management, we have functional and technical. QE, we offer functional testing, test automation, performance testing, security testing. We believe in providing end-to-end solutions. So if you see our solution portfolio, it's providing end-to-end deliverables. Now I'll pass it on to Prasanna, who will take you through the entire webinar, which is a core focus that is building a modern recommender system. Over to you, Prasanna.
Thank you, Rahul. So, hello everyone. My name is Prasanna Kumar. So, I'm leading the data science and the advanced analytics. So before we jump into the webinar, right? So I'll just walk you through some of the terms which will help you familiarize the recommender system. Now, recommender system on a broad scale, right? So you're going to hear that word interchangeably, be it recommender system or recommendation system. They both mean one and the same. In some context they use recommendation system, and then in some context they use recommender system, but basically they are used interchangeably across the industry. Now, first term which we are going to learn today is information filtering system. Now, information filtering system is a broad umbrella, and a recommender system is actually a part of a information filtering system. The goal of an information filtering system is basically to filter out some of the unwanted content and then display only relevant content to the user actually. So recommender system is one way of implementing an information filtering system. The next one is a recommender model. Now, a recommender model is a core AI-based model which will actually try scores against item which a user might be interested in. Now, when you say score, what we are referring to as, let's say the user has seen a video or he has liked a product. So he might try to predict, he might try to give a rating to it. So he might rate it as 4-star, 5-star, or probably I liked it, and I liked it very much. Some form of a rating. Now, what this recommender model does is it will actually try and predict it, saying that, okay, based on what I know about this user, based on what he has seen, based on his past history, I'm predicting it that this particular user is going to give it a rating of 4-star, or this particular user is going to give a rating of 3-star. That's a recommender model. A recommender model is what it will try and predict what a user will give a certain rating for that particular item. It could be a product, it could be movie, or it could be a music track, or it could be anything. Now, recommender model only is not enough to build an entire system. So you need other inputs also. You need other components like a filtering system, right? Let's say I'm trying to recommend the movies across the region. Now, let's say I'm an organization like Netflix. Now, I might have licensing rights only to certain regions. So I can onboard that telecast that movie only in certain region. So we need some kind of an information filtering system sitting on top of a recommender model saying that, you should not display this particular item to this particular user from this particular region. And also on top of it, right, what also lies is, let's say my recommender model has given me 10 items which it feels that I might like very much. Let's say which it feels that I will give 5-star to all of them. Now, you need a ranking and an ordering system also, which will decide eventually which item should be displayed first, which item should be displayed second, and so on actually. So a recommender system is actually a group of components along with the recommender model, which will eventually decide in what order, in what priority a certain item should be displayed to the user. Filter bubbles is one more interesting concept. Now, what filter bubbles says is a recommender model over a period of time start developing bias. Let's say I'm a person who likes soccer, or I'm a person who likes football. So what will happen is, over a period of time, the recommender model will start developing a skewed modification of me, a skewed person of me, and it will start recommending more and more of football videos or soccer videos. So filter bubble is such concept. It says that, no, we understand that this person likes football or soccer, but we would also like to add variety to what we are recommended. We don't want to just recommend only one type of videos or one type of products to him. Right? Cold start is one more very common problem in a recommender system. What basically cold start says is, let's say I have a new user or I have a new product item to add it to my catalog or list of my users. The first time that product is coming to the system, or the first time the user is logging the system, you still need to provide some kind of a recommendation to that particular user. So cold start deals with those kind of problems actually. So cold start says that, okay, if a user is logging into my system first time, I don't have no idea about what that person, I don't know the person of that user, I don't know what he likes, but how do I build my recommendation for such kind of system? Recommend cold start is a very common problem. So over the course of this webinar, we are also going to see how to handle some of this cold start. Personalized and non-personalized recommendations. So non-personalized recommendations on a high level are, let's say you are providing top 10 movies, top 10 products which we like. So they are on a high level saying that, hey, we have categorized you to belonging someone who belongs to, likes more and more of science fiction movies. So these are the top 10 movies we recommend. Personalized recommendations are within science fiction. Probably I like movies pertaining from certain director. Probably I like movies pertaining to only certain actors. So personalized recommendations are again personalized to the user actually. Couple of metrics whenever we start trying to measure how well my recommendation system is working, we start looking into something like predictive accuracy, classification, and rank accuracy. Predictive accuracy is, let's say the recommender model is providing a rating, saying that, hey, this particular user might give a rating of 5-star to this particular item. It could be a product, it could be a video, or it could be anything. So and what is the actual user rating, right? So sometimes based on historical data, we do know that the user has given a like or a dislike, or he has given a 4-star rating to it. Now my recommender model is also trying to predict, okay, he might give a 4-star. So we try to compare both of them based on historical data and see how accurate my model is. Classification accuracy is basically what kind the eventual decision making. Should I show this video to that particular user or not? Rank accuracy is when I display the order to the user. Let's say I display 10 videos to the user. What should be the ordering of it? Okay, so let's say I present a product or a video or anything to the user, right? So is he going to click through it, or is he just going to skip it and move on to the next one? So rank accuracy is how accurate is my ordering. So the key takeaways quickly. So what we are going to learn over the course of webinar is the space of recommender system. Now we all know that Netflix uses it, Amazon uses it, some of the social media like LinkedIn or Facebook or Instagram. There are a lot of other places where recommendation systems are being used. So just we'll quickly review and what are the other areas where a recommender system is being used. Evolution of recommender systems. So we're going to see that, how it's started as a small concept, and over the period of time it evolved into a huge system where, there are now multiple moving components, and then eventually some of the challenges also we'll review as we are reviewing each of the evaluation. We will see that, what was the first proposed model, and what were the challenges, and what was the final proposal model, and what kind of challenges we still have with it. And actually, if you are an organization, if you are a business leader, the most critical decision is, should I build it or should I buy it? So there are a lot of over-the-counter recommender systems also available. So let's say like a big commerce is one product which is readily available in the market. So should I build it? Should I build my own system, or should I buy? So what would be the criteria? What was the decision making for it? Roadmap. Let's say you decide to build it, or let's say you decide build or buy. How do you implement it? How do you this thing? And eventually the ROI and KPI. So how do you measure the return on investment? So I've given you a few metrics already as part of your introduction, like predictive accuracy, classification, and rank accuracy. But those are from the technical sides or some of the KPIs. But we will also see some of the metrics from the business side. Right? What is the goal? Moving on, what is the goal of a recommender system? Basically, the goal of any recommender system is, how do I filter out some of the content which is being showed to the user, so that I can present only that content which he's most likely interested in. The challenge is, let's say you take something like Netflix, right? It has a customer base of, user base of 23 million and some terabytes of data of movies actually. So now it has to match the user base along with their tastes actually. Amazon is one such product. It's we actually, Amazon has the best possible recommender system. Since they have huge profile of users, they have huge catalog, they have a lot of history also pertaining to what the historical purchases of him. LinkedIn, Facebook, right? Over a period of time, they have also matured some of those Instagram Reels or the short YouTube Shorts. So over a period of time, they have matured a lot, and people actually, the more they're spending time on some of these social media networks, then they are actually becoming more and more accurate. Same applies to music stations, huge volume of information. Now, we already talked about e-store, where recommender system are using. We already talked about product discovery. Now, product discovery is one such unique area. Largely, it deals with the market basket analysis. Let's say I'm buying bread. Along with bread, what else can you recommend to that user? Eggs? Can you recommend milk? Can you recommend milk also? So that is a product discovery. So e-store and product discovery is some of the most of the common features which you are aware. But recommender systems are also being used for customer loyalty programs, right? Let's say I'm a regular customer at Walmart. I've accumulated a certain points over a period of my purchases. Then I log in to redeem some of those points. So we have this amazing websites which can actually recommend. So based on your points available, these are some of the products which you can actually redeem actually. So that's also one niche area where recommender systems are being implemented to improve customer loyalty. Campaigns, right? So digital marketing campaigns, you have a lot of user base, you know what user is interacting for. So can I put together both of them and come up with certain campaigns which are specific to the users? Hey, I know that that particular user has been looking to buy a pair of shoes. Can I issue him a discount voucher so that I will tempt him to buy those things? So campaigns are also being. Search is one area. Any of your big search engines, they use some form of a recommender system. Now, we all know how complex search is, but eventually, once the search results are narrowed, then it thereon sets atop a recommender system, which will actually decide which of those search results need to be shown to you, right? They will try and decide that, which of those results should be categorized at the top, actually. Now, supply chain is one area where a recommender system is also being implemented, where it is trying to match, which is the best carrier and which is a supplier matching actually. So these are some of the areas, not known so much areas where recommender systems are coming into play. Right? Now we'll just look at how recommender systems have evolved over the period. Now, now collaborative filtering. If you are a new person or if you are trying to search about a recommender system in the first, so the first thing you're going to hear about collaborative filtering and collaborative system. Recommender system has been the first theoretical concept of recommender system has been proposed in 1960. The first actual implementation of a recommender system came in 1992 actually. And the concept was collaborative filtering. Now, what does collaborative filtering mean? Let's say I am a user, okay? Now, can I group this particular user with other set of users who have similar tastes, and can I recommend a certain set of products to him? Let's say, to begin with, I identify, let's say, I'm a person who likes a lot of science fiction movies, or I'm a person who likes, who has a toddler kid, and then I buy certain set of items. So what the system is trying to do is, okay, who are the other toddler parents, or who are the other people who like certain set of movies like this person, and then let's see what those users are buying, and can we recommend the same set to him. So that is one way of collaborative filtering. The other way is within collaborative filtering, we have also something called as item-based filtering. where we list down, we just focus on the items actually more than the user profile, the list of items a particular person is buying, and then we actually match saying that okay, along what are the similar items or this similar items or along with items which are being, right? So basic steps, very basic system. We'll try and identify a user, what his pros and cons by grouping it. Okay? So some of the pros is this is where requires requires minimal effort. So and then I really don't have to dig down deep into user preferences on this. I will do some user profiling, I will do some product profiling, but not at a level where we want to do a full scale profiling or full scale matching actually. So there are basic characteristics. Okay, but the challenge is it requires lots of amount of data. It suffers from something called as a popularity bias, right? So popularity bias is, let's say the system has identified me as belonging to, let's say, certain group 1. So what it will try to do is it will actually keep recommending what other people are buying, the more and more popular products in that group, right? So it suffers from popularity bias. It will not really recommend some of the items which are not unpopular or some which are not floating around. Assumes heuristic behavior. Let's say I've liked items, some certain set of items in the past. It works on assumption that I'm going to like the same set of items in the futures also. And cold start. So cold start is a problem where I'm a new user to a system. I really will not be able. The system will never not be able to identify me on which group do I fit actually. Nevertheless, if you're still a small system, a small application you're looking at a basic collaborative filtering is still good. Netflix was the first one to implement a collaborative system, collaborative filtering. They still use in some form, but now their system has much more allowed. But Netflix was the first organization which pioneered collaborative. Now we have seen that where collaborative filtering suffers, right? Now in comes the content-based filtering. What content-based filtering does is it will try and extract some of the characteristics of the products which I'm purchasing. Let's say I as a person walk in and then I like a lot of action movies, right? So within action movies, it will try and extract certain features. Okay, so it will extract like, yeah, like Hollywood movies, and then it will say it will extract saying that the runtime should not be more than 90 minutes. It will extract saying that okay, probably these are some of these settings which are required for him to like, right? So it will try and extract all those features, and then when what it will see is okay, now I've understood what kind of minimum features are required for a particular user to like, right? So I will see within my catalog which other movie or which other product has similar set of characteristics, similar set of features. So once I identify saying that, what I will do, I'll do a mix of user profile and the eventual product characteristics and start recommending to the user. Remember, we are not grouping here. We are trying to identify the characteristics of a particular product, right? So now the advantage here is the cold start problem. So how we are overcoming the cold start problem as initially, so let's say you are trying to identify whenever the user is signing up, you will probably give him a brief survey or something saying that, hey, can you select a couple of movies you like, or can you select what are products you're going to like, and then we'll build a brief profile of the user likings, and then we'll start extracting those features, and then it will do it. Can provide unique recommendations with unique tastes. Now, so now we are not limited to the number of groups, right? So I can just pull out certain characteristics and start recommending. So it also does not support from popularity bias, because let's say there is a new product or a new video or new item which is added to my catalog. So all I need is a characteristics of that particular item, and then if the characteristics matches what I like, then it is automatically recommended. It doesn't matter whether it is popular, unpopular, what other users feel or have a feeling about it. So it will straight away recommend to me saying that, hey, the characteristics seem to match. So I think you're going to like this. So it also has a good explainability. Now, explainability is the most common when any AI, actually not just to recommend a system, where if an AI model is making a decision, so why is it eventually making that decision? So explainability is very important. Even some of the deep neural networks have this issue. Actually, we cannot really tell why the model, the AI has made a particular decision. But in content-based filtering, this explainability problem is addressed, right? Now, what are some of the challenges? It has a lot of scalability issues, right? Really, if I have millions of products in my catalog, so you need some kind of a algorithm which will go in and then it will actually extract the scalability of all the, attributes of all these products, right? All the characteristics and everything. Now, attribute encoding, what is attribute encoding? Let's say I know that, let's say for a certain set of products, let's say for science fiction movies, these are some of the attributes which I have to extract. But let's assume that, there is a new type of products, or how many different combinations of attributes you're going to extract for it, right? So that attribute encoding is still a challenge. Today you are probably extracting 10 attributes. Tomorrow you need to extract 25 attributes. So that is still a challenge. But nevertheless, content-based filtering is still popular. It is being used by many of the news websites. Let's say I log in into a news aggregator platform like a Google News or some other news aggregator platform, and then I keep looking at certain types of news. Over a period of time, they will build my profile, and then they will say, okay, this particular person is more interested in news pertaining to, let's say, AI-based system, or this particular person is more interested in news pertaining to, let's say, how the economy is doing. So it's still very popular. So now this content base was first pioneered in 1998. Now YouTube had actually published a paper in around 2015-16 in the Rexus summit actually. So we have a annual summit called for Recommender System where they keep publishing all the papers. So one of the summits, YouTube had published the paper, and it's the first insight of how YouTube is actually working. So now YouTube has something called the two-stage recommender systems, right? So remember here we are actually have very basic candidate generation as well as ranking system, but YouTube has first defined saying that, hey, I have something called the candidate generation and a ranking. Both of these are deep learning based algorithms. Now what candidate generation is nothing but it will scan through this entire catalog, and then it will, for a particular user, it will try and extract, okay, what could be the possible recommendation for it. Millions of videos, I'm trying to say to some 100 videos, right? A given instant of time, I'm trying to narrow it down to 100. So millions of videos, I'm trying to narrow it down to 100 videos. So this is one deep learning based algorithms. And then what it will try to do is from within these 100 videos, it will try to build the user profile. It will try to build the context. Context in this case is basically my previous searches, what I'm trying to do, or what are the last 5-10 minutes, what work I've been trying to do. So it will try to build a context, and eventually we have another deep learning model which will actually rank or order these 100 items actually. So this is how YouTube works, but there are still some challenges to it. Still, it does not address the problem of really how are you going to filter out some of these things. Let's say when I'm building the candidates, right? Let's say there is a video which cannot be shown in a particular region. Let's assume it's a site like Amazon. There is one product which is out of stock. So there are still some issues. So those kind of features are also embedded in the YouTube model. But I will just show you enhancement on top of it, but this was a high level stage, high level implementation of a YouTube one. And eventually all these recommendations are served on the user interface. Right? Now, the 4-stage recommender models are the latest set of recommender models. It is implemented pretty much by an adaptation of all these recommender models. This 4-stage recommender model is implemented by many major sites. Netflix today works on a 4-stage recommender model. I know Facebook works, Instacart works, Alibaba also works on a 4-stage recommender model. So what does the 4-stage recommender model really stands for? So you have the first, retrieval. So this is an improvement over the YouTube 2-stage recommender model, where you have a retrieval, the candidates are generated. We have a filtering layer in the middle. This filtering layer really takes care of the entire whether to show that particular product to this or not. Now, really, this is instead of training the model to learn which videos or products should be shown to a particular user or not, a filtering is more rule-based system which will actually take care of it. So it actually works on a blue filter concept. A blue filter is a filtering concept where it works really fast at scale of nanoseconds to identify. Now, blue filters was first pioneered by Facebook, right? So blue filters were implemented by Facebook to determine whether a user can create a particular user ID or not. Right? Let's say I'm a new user. I'm trying to sign up something. So a Bloom filter will determine whether that particular user ID is available for the user to sign up or not. Right? And then you have a scoring model. A scoring is a more of a prediction algorithm, which will, from the hundreds, from the millions, the candidate list is drilled down to 100, and from 100, and now you have removed out, let's say 10 to 15 videos. Now you have 85 videos, and then the scoring model based on the user profile, it will actually really try to predict whether what would be the possible scores the user might provide. And then you really also have a ranking model also as part of it, right? So we have two different stages. We have a ranking model and an ordering model. So a ranking model will actually determine, hey, my preferences, you show this particular product at the top, this probably at the model. So that is what the algorithm is predicting it. But we also have an ordering model sitting on top of the ranking model. This ordering model is purely business driven, which will actually take the input and probably it will slightly rejig it. So what could be one of my business logic, right? It could be something like I want to show products at the top which will maximize my profit. I want, or it should be, I want to show products at the top which I can do a one-day delivery, an express delivery in it. So those are some of the business logics, right? So the model is going to provide its own ranking, but what we'll do is on top of it, we will build our own business logic, which will say that, okay, we are going to slightly reject that ranking. We're not going to entirely reject, but we are going to slightly reject that ranking to display a relevant this thing. Right? Now, 4-stage recommender system, I have to show, right? So if I look something like a social media, how does it work? So first thing, what it will try to do is it will try to identify any new posts in the users networks. Filtering would be, I have blocked a certain users, I have blocked a certain set of users, or I've muted a few users. So I'll remove all those from my filtering network. And then I will probably, the ranking, the scoring model will actually predict, saying that what is the likelihood that particular user is going to view that post or react to that post or do this. And then your ordering will really sit on top of your scoring model to adjust the rankings. Actually, same applies for a streaming service also, right? You will try to find the relevant items, remove items which are not available in a particular country, predict users stream or how much time he's going to watch that video, or his preference for it, and then we are going to organize recommendation. Now, having said that, these are huge systems, right? So if you look at the architecture, right? So what we have to do is we cannot really build some of these models in real time. So what we have to do is we have to follow an offline online architecture. You first train your model offline, and then you, whatever the learnings of the model is, you actually move it. So the bottom part of the line shows all the offline training and eventually how you're transporting to this thing. So there are still issues with it. So let's say you have a lot of data, right? Let's say you're talking like a YouTube or an Instagram, where uh, hours of video, millions of hours of video is getting uploaded per second. You cannot say that, hey, I'm going to train my model on all that data and then I'm going to push the learning set. It does not work that way, right? So really you have to follow some kind of a iterative training model where you say that, I'm going to train on this smaller subset of data, or I'm going to build a candidate selection and then train my model and quickly move it. So this online and offline transitions really needs to happen in real time, where as the data is getting loaded, model is getting trained, and it keeps pushing its learning to the network actually. Now many of these systems, right, many of these real desktop or mobile system, they cache a lot of data actually. Now remember, we were discussing about how it is so important to identify the context of the system. So many a times what happens is these contexts is stored in the caching of your desktop application, or basically it's stored in the cache actually. So how do you transfer all that cache to the learnings of the model, right? So you need a real good algorithm which will actually a model which will actually transfer all this cache data, all the learnings of this cache data into your model actually. And the complexity of these models is such that you need efficient logging and monitoring, because you cannot you have to really keep track of what is happening. So we have four different things, right? Let's say you have a ranking model which is trying to say saying that this should be the rank, the order in which the item should be shown to the user, and then you have an ordering model which is actually trying to reject that ranking. Now if you don't plan it properly, or if you're not monitoring it properly, right, eventually what will happen is all these models will actually working at cross purposes, and it will really impact your predictions, which are really impact. So logging and monitoring is also one of these issues actually. Now, coming to the organization. So this is the four stage. The four stage recommender system is really the new set of the latest recommender system. Now, which of these is more appropriate to you? We'll probably have to decide on a case by case basis. If you have small set of data, then we can probably go for one of the basic recommender system. But if you're dealing with large scale, we have to seriously look at a four stage recommender system. Now, what is the business impact, right? Let's say now if I have a system, if I'm an organization or e-store, let's take an example of an e-store, and then I have what is the business impact of not having a recommender system versus having a recommender system? So we clearly, some of the surveys are very clear, saying that click-through rates. Now click-through rates is you provide a recommendation, and whether the user skips through it or he will probably going to click it and then view further details. He's going to basically navigate into that whatever item you're showing, right? So the click-through rate. So we have seen clearly saying that if you have a proper recommendation system in place, we have seen a 39% increase in the click-through rates. Conversion rates, now 6% increase, because we are based on the recommendations you provided. Now 6% might seem like a small number, but when you're looking at millions of users and then millions of products, 6% eventually translates in a huge number actually. Sales and revenue, 45% jump in sales and revenue, 50% increase in user engagement, and then the sales distribution channels, 36% increase in sales distribution channels. comes here. Should I build it or should I buy it? Should I buy a over-the-counter product or should I build something from scratch? Actually, before you do that, right, some serious questions which you have to ponder is what is a recommender system, the core of your product, right? Let's say you're building an e-commerce website. So are you saying that, are you saying that, hey, providing accurate recommender systems is like the core of my product? If that is your AI goal, then we would suggest go for a build rather than a buy, because you are basing your entire product on how good your recommendations are. Right. The second question to ponder is a problem unique to you? Are you the first person who is trying to implement it? Right. So probably you might have really thought of some unique ranking algorithm which is unique to you. So in that case, also you might want to go for a build actually. Data privacy is one more thing. Now we deal with a lot of banking and financial customers. For them, data privacy is a huge component of any of their design decision making actually. So if you are saying that hey, data privacy is issue for it, probably in that case you have to see whether you want to build it or you want to use some of the cloud services. Competency of your IT team also matters, right? The time to market and the technical depth. Now, recommender system requires a lot of maintenance actually. Now, some of these maintenance tasks can be automated, it can be done, but there is a lot of technical depth you are incurring. Customization for over the shelf product. Let's say I buy a product, right? How much customizations do they allow me actually? So is it so that for every customization I ask them, they're going to charge a lot of money? Probably they will give me a basic recommender system. After that, every customization or everything which I ask, it costs me a lot of money. Right now, build versus buy is somewhere or not a binary decision, right? So you can actually hire initially. So we understand that it involves a lot of maintenance, but you can probably hire a competent IT team who can build you, someone like AppsTek who can build you the product, and then they will transition to your team actually. They will hand over all the product, the entire code base, the entire how to maintain the maintenance logs, everything to your team, and then from your team can take it over. So you don't have to build everything from scratch, or you don't have to buy. You can also have this strategy where you really hire a third-party provider who will build you and then transition to your team actually. Now, go-to-market strategy. So we have seen so much time, So as I said, right, there are at least two components where business logic is involved: your filtering component, your ranking component. So you have to be very clear in your business goals. The recommender system can provide its own ranking, but at the end of the day, you need some kind of on how you want to recommend certain products actually. So customer experience is key. So your strategy has to be around customer experience. Level of complexity, right? So when you sit with your actual technical team or design team, you have to determine what is the level of complexity which is involved in it. Based on it, you have to determine your go-to-market strategy. List channels want your support. Now, a recommender system logic might be same, but it involves large compute power. So recommending for a mobile app would be slightly different versus recommending for a web app actually. So you have to clearly define what all channels you want to support. Risks we have already talked about. Technology strategy, but usually we always recommend you start small, measure and iterate. Let's say I start with implementing for a small geography, and then I measure how good it is, and then I slowly start expanding it to our other geography. Or if you are some kind of a e-store, then you start with one small product line and then start rolling out to other. Okay. Critical success factors. At the end of the day, how good your personalization software is, right? So you have to gather some kind of a feedback from the users on this thing. So there are direct ways, there are indirect ways. Direct ways is a user providing rating. Indirect ways is, let's say, did he drill down what are the click-through rates? Quality of data, right? Many times I have a lot of data, but is this particular that data relevant to building a recommender system? The quality of data available also this thing. Compute power, recommender systems are huge compute intensive actually. The more data you have, the more time it will take to process, and then the compute system happens. So sales funnel. So we have seen the technical piece of it. Really on the measuring the ROI side, we are looking at the sales volumes. Okay, so at the end of the day, if you are a business, the sales volumes matter. Motivations matter. So motivations is, let's say you're talking about personalizations. So have the personalization goals being met, have your ranking orders being this thing. Indirect sales volume, we have seen that recommendation systems so help increase the indirect sales volume. So how much the indirect sales volume, how much impact is there on the indirect sales volume? Really the user experience. So it could be direct, you can measure direct from the feedback, or there are other ways also, like the way YouTube measures through indirect user experience, and then how users eventually feel the perception of your service. So moving on, we'll talk about the last section of it, what the future looks like. Now the best recommender system even today involves a combination of offline training and pushing their learnings to online, right? So at some stage, we are looking at real time, where the recommender system will learn in real time and then it will start incorporating. So the future looks like where we have a really reinforcement learning, which will learn on the fly and then start doing recommendations. Recommendations at a personal level, still somewhere some kind of a collaborative and content-based filtering is being implied, but that user profiling and then the user context building, that still needs an improvement. We are seeing rapid side. Every year we have the, as I said, Rexis conference. Every year new papers are being presented on how the ranking model should work, how the candidate generation model is being. Expanding into different domains. Now, recommender systems have made great strides in certain domains, but there are still certain domains which they're still novice actually. Something like a medical domain. That's still a lot of improvements need to be made. So, but eventually we'll see. We are seeing that we will reach that stage also. Better engines will determine industry leaders and laggards. Really, if you need a recommender system in one form or the other. The better your recommender system, the more successful your product is going to be. Eventually, if you have a bad recommender system, you're going to see that in your user feedback. Generative models for plus recommender system. Now, generative models are models which can actually create content on the fly. Let's say a recommender system is recommending you a product, but you don't have a visualization of it. So a generative model can create a visualization, a picture for you on the fly, and then it can paint you. So recommender system plus generative models are a new avenue which is being explored actually. And finally, personal bots interacting with brand bots, right? So you have a Alexa, you have a Siri, where there is a lot of your context, your personalization involved. And let's assume you have something like a Amazon, right? Can Siri, which has your context, which has your personalization, interact with really the Amazon service and then pull out the right products for you? Or a Netflix would be a better example. Can Siri interact with your Netflix service and provide you the right recommendation? So that is the future. So that we now come to the end of the presentation. So I will take some time and see if you have any Q&A.
Thank you, Prasanna. I'm sure we added value to the attendees. We have received some questions. Let me share them with you since we have some time. So the first question is from Andrew. He's asking, what are some of the domain-specific challenges for recommender system?
So one of the challenge which we see with the recommender system is like the building the context, right? So let's say you're trying to understand. So there are certain recommendations which I can make based on historical data, but I really need to understand the context on what the user, which the user is still looking at. So now context becomes very important in certain cases, right? Let's say I'm really having a bad day, right? I want to see a certain kind of movie. So the bad day context is very important, actually. So that is, building that context is one challenge, especially for a streaming service. Geolocation based services. Let's say I'm in a certain location. I'm looking for certain, let's say, based on the weather, I'm looking for certain products. So location based, some of his recommendation is some of the challenges. Time based recommendation are also some of the challenge. What is recommended, what is useful yesterday as a recommendation, today it might not be useful in certain cases. So those are some of the challenges specific to domains we are looking at.
Okay. We have Rashid. He wants you to talk a little on knowledge-based recommender system.
So now knowledge-based recommender system is one of the solution for the cold start, right? So let's say I have a user who is completely new to my system. I have no idea about what it is, right? Now, one of the solutions for one of this cold start problem is, what can I derive from the user interaction? So he has searched for, let's say he has searched for X, he has searched for Y. So I'm slowly starting to build a context, or he has clicked on a certain link. He has tried to navigate to a certain video, and he has watched this video for 2 minutes. So what the way knowledge-based system work is, you are trying to build the persona of an unknown user based on the interactions which he has within the system, and then you try to build a recommendation for him.
Okay. We have Satya. He's asking how much time does a recommender system usually take to build?
So recommender systems, it really comes down to, the data, the volume of data you have, the quality of data, and then, as I said in my 4-stage recommender model, right? Whether you need that additional filtering logics, the ranking logics, and everything. So if I am looking at a small scale, very basic recommender system, then probably somewhere around 4 months should be good, from, let's say, conceptualization to implementation. But if I'm looking at a complex recommender system where recommendation is the core of my product, then somewhere it will take around 8 to 10 months.
Okay. We have Herman. Who's asking what are some of the analytics which are associated with recommender system?
So some of the analytics which are associated is, now we really want to, the core of any the goal of any recommender system is how much personalization it is able to give to that particular user. So we will usually gather those personalization related metrics through direct interaction, direct ratings, or indirect ratings. So the analytics which we are trying to run here is, how is my recommender system performing over a period of time? So that is one thing. The second thing is, the way recommender system also work is through A and B, actually. So A and B testing, right? So I will deploy a certain version of a recommender system and release it to my core users, only a certain set of users. Let's say let's say 1,000 users are browsing my system. I'll probably try and deploy it to only 50 users, and then see how the interactions are happening over there. If there is good, then I will probably roll it out to the other set of users. Otherwise, I will roll it back. The other analytics would be more business specific, like sales volumes, the indirect volumes which are happening, and then how my recommender system is it facing a data drift or a model drift over a period of time.
Okay, I have Sabine. It's an interesting question. How difficult or easy is for her team to maintain the system if AppsTek builds one and transitions it to her team?
So, okay, so let me split this into two parts, right? When AppsTek builds and transitions it to her team, right? So we'll do a real handoff, we'll a training where we say that, you know, hey, this is how your system works. These are the key metrics you have to keep looking at your system. This is at this point you have to retrain your model. If you have new products coming to the system or new users coming into the system, this is how you have to monitor. So we'll do a complete handoff of this thing. So there would be a training period. There would where we will actually they will work along with us. There would be a few weeks of training, and then there would be a handoff period where her team will be actually doing the primary support, and we'll just be supporting from the background to it. And then we'll also give them a roadmap saying that, okay, in future, you'll probably have to look into these systems. So that entire handoff along with the documentation, along with the training is provided to her team. So that is one thing. The second case is more complex recommender systems, right? Like something like a Netflix or a YouTube where we are looking at millions of products and millions of users, right? So in those cases, we'll probably provide a longer handoff period or longer training period for them. But overall, once a recommender system comes to a stage, right, I think it should be simple for them to continue working on it.
Okay, with that, we'll conclude the webinar. We have few questions unanswered. We'll reach out to you with the responses on your email. Thank you for being a patient audience.